Okay, let's have a look at example 3. I'll show you a few different ways because on the slide it does say using a spreadsheet. But let's read the question first of all. So it says a school basketball coach kept a record of number of players, games played, points scored. Obviously the independent variable is games played and the points depends on the number of games played. Use Pearsons Correlation coefficient to determine the strength of the correlation between the number of games played and the number of points scored. Okay, so obviously we've got access to a GDC. Let's use our spreadsheet, list and spreadsheets to do this. So we need our number of games and we need the points. So we put that in A and B that represents our X and our Y variables. Next thing we have to do is input the data, 5, 6, and 10. And so let's just double check. 1, 2, 3, 4, 5, 6, 7 players. We've got 7 pieces of information. That's great. 9, 10, 20, 29, and 43. Okay, so we've got our data in. It matches. Okay, so the easiest and quickest way to calculate R, or Pearson's Correlation Coefficient, product moment correlation coefficient, is menu. Statistics, stat calculation. Okay, we are doing 2 variable statistics. So there's one, each player has 2 variables that have been collected about them. So we're going to go 2 variable statistics. Where do we put our X data? Well, we called that games. Where do we put the Y data? We called that points. Frequency list, we've got 1 of each. We don't need the category or include categories. And we want our first result column in C column. So we'll just click OK. And that spits out a series of values. So it tells us that X bar is 5.14. It tells us that sigma X is 36. Sigma X squared is 218. Standard deviation is 2.17. There's 7 pieces of data. Average Y is 21, so the average point scored is 21. Sigma Y is 147, so there's 140, which is the same total. Sigma Y squared is 3,927. Sigma X is 11.0. Sigma XY is 915, and then it gives us that R value. So that's the Pearson's correlation coefficient, Pearson's product moment correlation coefficient. So it gives us a value of 0.957, which tells us there's a very good correlation, which, well, common sense wise, the more games you play, the likelihood is you're going to score more points. If you look at the formulas and you want to calculate R as the covariance of X, Y, and sigma X times sigma Y, you have those values here. So you have sigma XY, this value 915, minus sigma X, so minus sigma X is here 36, times, and then sigma Y is that 147 divided by 11. That will tell you the covariance. You're given the standard deviation. Okay, standard deviation of X is there, but if you want to go through the calculations, sigma X squared is there, and then sigma X, and you just have to square that value, divide by 7, etc. to get those values. So all of those values that you need for the formula are given to you there, but the calculator also works out that value is 0.957. Okay, so that's how you do it on the GDC. If you wanted to do it on a spreadsheet, it's as easy. Let's just, where's it gone? There. So calculating R, you can just about see it. I know I've cut it off a little bit, but we've got the same data. And because we're looking at Pearson's product moment correlation coefficient, all we have to do in this is type in Correl, so Correl. But we have to be careful about how we input our data, okay? So because we're actually doing a Y on X regression, we need to put in our Y data first, and then we put in our X data separated by a comma, press enter, and we get 0.957, which is the same value as previously.